Hi everybody!
My name is Kurnia.
And I am Jilvi.
And I am Owen.
In this occasion, we are going to discuss the role of coordinate system in daily life.
Follow our adventure.
Hello, good morning, Dilvi.
Morning, Kurnia. I know. You surely want to talk about our project assignment, right?
That's right. I think we have to meet. But do you have any idea for the place?
Sure. I recommend two places. You choose my house or at Nang Ujang's Eatery.
Well, that's fine. But I don't know where is Mang Ujang's eatery. I don't even know where is your house.
Oh, alright. Okay. I will share the location. Later you choose the place and please chat me.
Okay, deal.
Okay, see you.
See you. How to read this map?
What are you thinking, Kurnia? You seem to be confused.
Yeah, Owen, I need to finish the task with Dilvi, but I have to decide the place. The nearest place will be better. And yeah, you know myself, I can read Google Map.
It's easy, Kurnia. If we look at this map, it's like a Cartesian coordinate system, you know?
Oh, how do you know?
Yeah, this is Alan.
Yeah, sure.
So, this Google Maps is an application of the coordinate system in our life. Let's learn more. Check it out.
Cartesian coordinate system is a coordinate system in the form of an arrangement of lines and points in two dimensions. The Cartesian coordinate system was invented by a French philosopher, mathematician, and scientist named René Descartes. In Cartesian coordinates, we will recognize several things. They are the position of the point, which includes the position of the point to the origin, the position of the point to the x-axis, and the position of the point to the y-axis. We also recognize the position of the line, that includes parallel lines, intersecting lines, and perpendicular lines. In this Kurnia's case is an example of the position between points. Cartesian coordinates have two-dimensional lines. They are x-axis as the horizontal line and y-axis as the vertical line. X-axis and y-axis intersect at right angle at point 0, 0. That can be called the origin point. The x-axis and y-axis are called number lines because they show infinite negative numbers until positive infinity. The area with positive x and y is called quadrant 1. The area with negative x and positive y is called quadrant 2. The area with negative x and y is called quadrant 3, and the area with positive x and negative y is called quadrant 4. Here is an example of a Cartesian plane. For example, let's find and analyze points A, 4,3, B, -2, -2, and C, -6,2. Before that, we can notice that the first one, the position of a point is denoted by P, x, y, where x is coordinates on the x-axis and y is coordinates in the y-axis. For example, we have point A, 4,3. 4 shows the coordinate on the x-axis and 3 shows the coordinate on the y-axis. The second one, the positive and negative sign in x-coordinate determine the position of the point to the right or left of the origin, and the positive and negative sign in the y-coordinate determine the position of the point up or down of the origin. For example, the position of point A is 4 units to the right and 2 units up. Then point B is 2 units to the left and 2 units down. And point C is 6 units to the left and 2 units up. The third one. X-coordinate determine the distance of the point from y-axis. Y-coordinate determine the distance of the point from x-axis. For example, the position of point A is 4 units from y-axis and 3 units from x-axis. The position of point B is 2 units from y-axis and 2 units from x-axis. The position of point C is 6 units from y-axis and 2 units from x-axis. From this example, we can conclude that first, the position of the point with respect to the x and y-axis. Here we can make a table that consists of point coordinates, distance to x-axis, and distance to y-axis. So, how to determine the distance? Well, please pay attention to the footnote, yeah?
So x determine the distance to y-axis and y determine the distance to x-axis, right?
Yeah, you're right. And don't forget that distance is always absolute value. The sign positive and negative only determine the direction, left or right, and up or down. Well, previously, we have point A, B, and C. What do you think to fill the table, Kurnia?
Yeah, I think point A is 3 units from x-axis and 4 units from y-axis. Point B is 2 units from x-axis and 2 units from y-axis. Point C is 2 units from x-axis and 6 units from y-axis. Is it true, Owen?
Alright! Let's go to the next topic. The second topic is the position of the point with respect to the origin. Here we can make a table that consists of point coordinates and the position from the origin. So, how we can determine the position from the origin? Don't forget to check the footnote, yeah? Come on, you can fill the table, Kurnia. Whoa, kakoi! Good job! Let's go to the next topic. The third topic. The third topic is the position of the point with respect to the curtain point. Previously, we have 3 points A, B, C. Where is the position of point A from point C? The position of point A from point C is 10 units to the right and 1 unit up. So, how about position of point C from point A? The position of point C from point A is 10 units to the left and 1 unit down. What can you conclude, Kurnia?
If we have 2 points, for example, Pxy and Qx prime y prime, it seems for quick calculation without drawing, we can reduce the P terms by the Q terms. So, x prime and y prime.
That's right! You saw the footnote. We really have to remember that if the sentence is P from Q, then P minus Q. Even when the sentence is position Q from P, then Q minus P. Well, letter up and down and left or right, that's according to the sign. Now, I have a table that consists of point coordinates, the position from A, and the position from C. Let's try and analyze the distance of each point from A and from C. Wow, good job! Sugoi! Well, that is the coordinate system, guys. Now, let's help Kurnia to determine the closest place. let's solve Kurnia's case. Here, we can assume the Mandurarejo Street as the x-axis and the Diponegoro Street as the y-axis. And don't forget 0 km monument as the origin point. As we know, Dilvi's house in the Kriya Sarana Mukti housing, Kurnia's home at Mr. Wawan's boarding house, and Mang Ujang's eatery is here. This is the illustration of map in its Cartesian plane. Kurnia have to choose to meet at Dilvi's house or at Mang Ujang's eatery. Which do you think is the closest? Let's calculate it using the Cartesian coordinate system. Dilvi's house is at point -10,3, while Kurnia's boarding house is at point 5,-5. To calculate the distance from Kurnia to Dilvi, we're using d minus k. Finally, we obtain -15,8, and it means that Kurnia is go 15 units to the left and 8 units up, and the total distance is 23 units. Manually, to reach Dilvi's house, Kurnia has to walk 5 units to the west, 5 units to the north to the 0 km monument, then 10 units west, and 3 units to the north. Yahoo! Alright!
Suka.
Then, what if Kurnia goes to Mang Ujang's eatery? Mang Ujang's eatery is at point 0,4, while Kurnia is at point 5,-5. To calculate the distance from Kurnia to Mang Ujang's eatery, we can using b minus k. Finally, we obtain -5,9, and it is mean that Kurnia is go 5 units to the left and 9 units up, and the total distance is 14 units. Let's prove it manually. Manually, to reach Mang Ujang's eatery, Kurnia has to walk 5 units to the west, 5 units to the north, and 4 units to the north. Yahoo! Alright!
So, how have you made your decision?
Yes, Owen, thanks for helping. It's very helpful. I will inform Dilvi to meet at Mang Ujang's eatery.
Ho ho ho! Okay, Kurnia. Using Google Maps is easy, right?
Yeah, you're right, Owen. It turned out that Google Maps has something to do with math.
Of course, this Gmaps is one of technological development in mathematics. So, Gmaps includes content. Nah, to check your understanding, I have a few bonus questions.
Oh, bonus questions.
Yeah, based on the illustration, how far does Dilvi go to Mang Ujang's eatery?
Oh, that's an easy question. Come on, guys, you can answer in the comments column. I want to meet Dilvi first. Bye. Thanks, Owen.
Ho bye!
Hi Dilvi, finally I arrived.
Hello, Kurnia.
By the way, Dilvi, your scarf is so interesting. It's like there is a mathematic element in there.
Oh, really? How come?
Owen!
That's right! Dilvi's graph consists the element of mathematics, especially Cartesian coordinates. The pattern contained in the body clouds formed by Dilvi are neatly arranged and connected to each other, so that they look like parallel lines. The patterns are connected in vertical and horizontal lines, then fill with pattern in the empty space to create an interesting visual. For the next, please Kurnia, you can try to explain why you think so.
Okay, after learning Cartesian coordinates with Owen, now I understand. Let me explain. Pay attention to the following figure. By paying attention to the following figure,
We can study the position of the line with respect to the x-axis and y-axis in the Cartesian coordinate. Now let's create the line L1 and L2 to be our initial horizontal line. And then continue with equidistant line for the next. And next, we create the line M1 and M2 to be our initial vertical line. And then continue with equidistant line for the next. The following is an illustration of the position of a line in a plane, even though it's not precise as a pattern. In the illustration, it can be seen that the line L1 is parallel to line L2, line L3, and so on until line L10. And so, with the line M1, it is parallel to the line M2, line M3, and so on until line M10. Now, how about the position of the line with respect to the x-axis and y-axis in the Cartesian coordinate? The position of lines L and M about the x-axis and y-axis can be described as follows. Look at the following figure. The first is a line that is parallel to the x-axis and intersect the y-axis, just like the following figure. The lines L1, lines L2, lines L3, and so on until lines L10, it is a line that perpendicular to y-axis, and it's lines that parallel to x-axis. The next is a figure of a line that is parallel to the y-axis and intersect the x-axis. We can see from the figure that lines M1, lines M2, lines M3, and so on until lines M10 is a lines that perpendicular to the x-axis, and it's a lines that parallel to y-axis. We can also take advantage to create our pattern by taking the line that intersect the x-axis and y-axis, like this. We can see in the figure that lines N1, lines N2, lines N3, and so on until lines N10 is a line that is intersect the x-axis and y-axis. From the figure, we can make a table and determine which lines are parallel, perpendicular, and intersect the x-axis and y-axis. Now that we know the shape of the line, let's combine our lines into coordinate Cartesian. I suggest to use the help of GeoGebra application to make it clear. You can access it by downloading the application, or you can access it online through the website geogebra.org. After forming parallel lines and intersecting the x and y axis, we can make batik pattern to fill in the blanks. Now, we already create the batik. But as a student, we also need to implement the knowledge by self, not using the help of tools. So, let's try to draw it manually too. First, let's prepare the tools and materials. There are pencil, ballpoints, eraser, grid paper, and rulers. We first create a Cartesian coordinate on grid paper using a pencil with the help of a ruler. Then, make parallel lines or intersection of x-axis and y-axis. Here, I give a distance of 2 blocks so that the pattern is not too small. Fill in the empty space using your favorite pattern using a ballpoint. After that, erase the existing auxiliary lines using eraser.
Wah, that's right. This batik consists the element of mathematics.
That's right, Dilvi. Basic problem that involve mathematical element can also be called ethnomathematics. Ethnomathematics is a form of culture-based learning in the context of mathematics. Ethnomathematics is analogous to a lens for viewing and understanding mathematics as a cultural product. Not only that, there are so many things in our daily life that involve ethnomathematics. For example, woven bamboo, batik bakaran, candi Borobudur, and so on. By the way, Dil, I was so confused because I can read Google Maps. But luckily, Alan taught me about Cartesian coordinate so that I can know the distance between your house or the E3.
Oh, really?
Yes.
You compute the distance with Cartesian coordinate?
Yes?
Oh my god, it's actually just like this. You can write in here,
Okay.
and then in here.
Hmm?
Now you can see the distance.
Oh my, just that?
Yes, just that.
Hi.
Alan,